All right, so we want to talk about extraneous solutions. So, a little bit about extraneous solutions. It's going to be a solution to an equation, but it's not actually a valid solution to the problem. So, when you check your answer or when you verify whether it's a solution to the equation or not, it ends up not checking out. So, it's not actually a solution. It's kind of like a false or fake solution, okay? So we're going to have to check our answers when we do our absolute value equations today. The types of equations where you would need to check your answer or where you would need to look for extraneous solutions are equations like this one. Okay, the difference in this type of equation and the one that we did previously is we now have two x's, one on each side, okay? One is inside of the absolute value and one is not. Okay, so when that is the case, this is when you are going to have to check for extraneous solutions. Okay, you're still going to get two answers. Both of those answers could be a solution, or one or both of those answers could actually be extraneous solutions. All right, so we're going to look at this first example. For this absolute value equation, we're going to solve it just like we were before, okay? Only extraneous solutions come into the end once you get your answers, and then you need to check to see which ones work and which ones could be extraneous, okay? So, as before, you still have to isolate your absolute value. So if we look, here's what separates our left side from our right side. On this left side where my absolute value is, there's nothing out front or behind the absolute value. Everything is contained inside of our absolute values. So our absolute value is isolated. It is by itself, okay? So that means we are good to go. We can go ahead and rewrite our equation into the two separate equations that we're going to solve, right? Or two different scenarios. So the first one, just like before, you're keeping everything how it is. We're just getting rid of the absolute value bars, right? So we're going to say 3x plus 2 equals 4x plus 5. That is one of our equations. For the second one, just like before, you're not changing the part that's inside of the absolute value ever. So we're keeping 3x plus 2 exactly how it is. And then we're going to make the other one have a negative answer, okay? Right? The other side's going to be negative. But I'm not just going to make the 4x negative, right? What I want to do is I'm going to distribute a 4x. Oops, and I ran off the page. I'm going to distribute this negative to the whole side, right? So essentially, I'm going to change the sign of both, right? So leaving this how it is, we're distributing that negative to both terms on the right side, both things inside of the parentheses now. So I would have a negative 4x minus 5. Okay, so those are our two equations. And now we're going to solve them. So we have x's on left and right side. We need to get them to the same side. It does not matter which side you move to. Does not matter. Okay? So let's just subtract a 4x from both sides. Why not? 4x minus 4x is 0. 3x minus a 4x leaves us with a negative 1x. Bring down our plus 2, bring down our equals, and bring down our plus 5. If you like the line down the middle, or down your equal sign, so you can see left side and right side, go ahead. I don't know how I put a positive there. Alright. So then, to get x by itself, we then need to get rid of this plus 2 by doing the opposite, and we're going to do minus 2. Bring down that negative x equals 5 minus 2 is 3. We're not done because our x is negative. We want positive x. So to cancel out just a negative, we're just going to divide by a negative 1. Negative and a negative cancel. X divided by 1 is just x. And 3 divided by a negative 1 is a negative 3. Okay? This is one of our answers right now. Okay? This is one of our solutions. But like I said before, when you have two x's, one inside of your absolute value and one on the outside, we're going to have to go back and check for extraneous solutions. So temporarily, this is one of my answers, but I have to go back and check it, and we'll look at that in a minute. Okay? Let's finish solving. So our second equation, once again, we have to get our x's to the same side. It does not matter whether I move the x to the left or the x to the right, or whether I cancel out the negative 4x or the positive 3x. Doesn't matter. So let's do it different this time. Let's subtract a 3x from both sides. Okay. 3x minus 3x is 0. So we get 2 equals negative 4x minus 3x is a negative 7x. Bring down our minus 5. To get x by itself, we want to cancel out this term being subtracted. So we're going to add. Okay. So we have 7 equals a negative 7x. To get x by itself, we need to cancel out this negative 7 that's multiplied by it. So we're going to divide both sides by a negative 7. Negatives make it positive. 7 divided by 7 is 1. So I have 1x equals 7 divided by a negative 7 gives us a negative 1. So there's our second possible answer. Okay, we have x equals a negative 3 and x equals a negative 1. So now we have to check those answers. Okay, when you check your answer, right, you're always going to go back up to where you got your absolute value isolated. This is what you're using to check your answers. This is what we're going to use to check our answers, right? So I'm going to go down, we'll have a little space, and I'm going to rewrite where I had my absolute value isolated, right? I'm rewriting it because this is what I'm going to use. So first thing I'm going to check is I'm going to check that x equals a negative 3. So all I'm going to do is I'm going to take this and I'm going to plug in a negative 3 for wherever I see x. So I have the absolute value of 3, right? But instead of x, I'm plugging in negative 3. Oops. And then bring down my plus 2, absolute value equals 4. Instead of x, I'm plugging in negative 3 plus 5. Okay? So 3 times a negative 3 is a negative 9. Negative 9 plus 2 gives me a negative 7. Equals 4 times negative 3 is negative 12. Negative 12 plus 5 gives me a negative 7. Okay? Some of y'all might look at this and see, oh, negative 7 and negative 7, it checks out. But that is not correct. Okay? I still have my absolute values around that negative 7. And you know, absolute value, when you take the absolute value of a number, your answer is always positive. Okay? Because this means the distance negative 7 is from 0. Well, negative 7 is 7 units away from 0. So the absolute value of negative 7 is 7. And is 7 actually equal to a negative 7? This is not a true statement. Okay? Not true statement, which means we have our first extraneous solution. okay? Which means x equals -3 does not work. That is not a solution. Okay? So now we need to see whether x equals -1 is a solution. If not, then we have no solutions, right? Because this one's already been crossed out. So now we're going to check x equals -1. Check x equals -1. And we're still using this same original equation where we isolated our absolute value. Okay? So our absolute value of 3 times, instead of x, I'm putting in my -1, plus 2 equals 4 times, instead of x, I'm putting in a -1, plus 5. Okay? And then we're going to simplify just like we did on the other side. So inside of my absolute values, I'm going to have 3 times -1, which is -3. And -3 plus 2 leaves us with -1 equals 4 times -1 is a -4. -4 plus 5 is a +1. The absolute value of -1 is 1. So we get 1 equals 1. Is 1 equal to 1? This is a true statement. 1 is equal to 1. That is true. So since 1 equals 1, that means it checks out. X equals -1 is a solution. So this is our whole answer. All right, another example. These take a little bit more time because you have to check your answers. So I'm going to try to go a little bit quicker so we can get through another one. As always, you have to isolate your absolute value. If you'll notice, on this left side of my equal sign, there's a 2 and a -10x that's on the outside of absolute values. So we need to isolate the absolute value. The first thing we're going to do is we're going to cancel out a -10x by doing the opposite and adding 10x. If I do it to one side, I need to do it to the other side. Okay? So then that cancels out, and we have 2 times the absolute value of 3x plus 5 equals 4 plus 10x. These are not like terms. You cannot combine them. So we just leave it as 4 plus 10x. You can't combine those. One has an x and one doesn't. They are not like terms, right? And that's a bar, not a parenthesis. Okay. Now our absolute value is still not by itself. We still have this 2 out front. Okay, so it's being multiplied. To cancel it out, we're going to do the opposite, and we're going to divide. And then if I divide that side by 2, I need to divide both things on this side by 2 as well. Okay, so we have the absolute value of 3x plus 5 equals 4 divided by 2 is 2. 10x divided by 2 is a 5x. Right? Now my absolute value is isolated. Okay? So from here I can set up my 2 different scenarios, my 2 different equations, right? So the first one, you leave it exactly how it is. Just drop the absolute value bars. So we're going to say 3x plus 5 equals 2 plus 5x. And then for the second one, we're leaving 3x plus 5 exactly how it was. And then we're going to negate the right side. We're going to distribute a negative to everything on that right side. Okay, so I'd have 3x plus 5 equals negative times a positive 2 makes it a -2. Negative times a positive 5x makes it a -5x. Okay, And now we can solve these two equations to see our solutions. Have x's on both sides, right? Left side and right side. I need to get them to the same side. So I'm going to do a minus 3x on both sides. We have 5 equals 2 plus 2x. Subtract 2 from both sides. And we get 3 equals 2x. Divide both sides by 2. And we get that x equals, and we can just leave that as 3/2. Okay, this is one possible solution. If you notice right here, once we isolated our absolute value, I have x's inside of my absolute value and x's on the outside of the absolute value, which means I could have a possible extraneous solution. So I'm going to have to check that answer. Okay. And then on the right side, or our second equation, once again, we need to get our x's onto the same side. It does not matter which side you do this to. I'm going to add 5x to both sides. So we get 8x plus 5 equals a negative 2. I'll subtract 5 from both sides. And I get 8x equals a negative 7. Divide both sides by 8. And we get that x equals a negative, we can leave it as negative 7 over 8 because that fraction does not simplify. All right, so we're going to go back to our original equation once we got the absolute value isolated. All right, so this is the one that we're going to use. I'm going to rewrite it down below just so I'm clear about what I'm using to plug our answers into to check, okay? So the first one I'm going to check is that x equals 3/2. Okay? So I have the absolute value of 3. Instead of x, I'm putting 3/2 plus 5 equals 2 plus 5 times 3/2. Okay? So 3 times 3/2, 3 times 3 is 9, divided by 2. We can leave that as 9/2. Because really this is like 3 over 1 times 3 over 2. So 3 times 3 is 9. 1 times 2 is 2. Plus 5 equals 2 plus 5 times 3 is 15. 1 times 2 is 2. Okay. Now we need to combine these. So if you remember rules of fractions, or if not, you can use your calculator and add 9/2 plus 5, right? So really 5 is like 5 over 1. If you want to have the same denominator, to get 1 to be a 2, you would multiply by 2, right? So you're adding, I'm going to do it off to the side, 9/2 plus 5 times 2 is 10. 1 times 2 is 2. So really we would have the absolute value of 19/2 equals, and same thing here. Okay, to make them have the same denominator, you're multiplying top and bottom by 2. So that on the bottom we would have, and I'm going to go off to the side again, 2 times 2 is 4, so 4/2 plus 15/2 would give me 4 plus 15 is 19 over 2. Absolute value of 19 over 2 is 19 over 2. So you get 19/2 equals 19/2. That checks out. This is true, which means x equals 3/2 is a solution. Okay, so there's one of our answers. Now we need to check our second possible solution, which was a negative 7/2. Okay, So we're going to check the absolute value of, ignore that, we're checking x equals negative 7/8. Alright, so the absolute value of 3 times negative 7/8 plus 5 equals 2 plus 5 times negative 7/8. Okay? Alright, so we're going to simplify. 3 times the negative 7 would give us negative 21 over 8 plus 5 equals 2 times 5, or 2 plus 5 times the negative 7 would be a negative 35 over 1 times 8, which is 8. Alright, so for this one, I'm actually going to do the right side first because I know absolute value can never equal a negative number, right? So I'm going to go ahead and simplify this right side because if the right side ends up equaling a negative, my absolute value can't equal a negative, so I would automatically know that this was an extraneous solution. Okay, so let's check it. In order to combine these through addition or subtraction, in this case it's subtraction, I need them to have the same denominator. Right now 2 is just the same as 2 over 1. They have different denominators, right? So to make them have the same denominator, I would need to multiply both top and bottom by 8 to make them both have a denominator of 8. So if I multiplied both by 8, then I get 2 times 8 is 16, 1 times 8 is 8, minus 35/8. So that gives us negative 19 over 8. A negative. So is there any point in me simplifying this left side? No, because I have absolute value equals a negative number, which we know is not possible. Therefore, this is an extraneous solution. So our only real solution is that x equals 3/2.